In the world of AI, we absolutely love a good rivalry. It's what pushes everything forward. And today, we are diving into one of the biggest comeback stories in recent memory, how a classic champion of computer vision took on a revolutionary new challenger and clawed its way right back to the top. And really, that's the big question here, isn't it? For years, one type of algorithm was king. But when a new contender burst onto the scene, everyone started wondering if the old guard's time was finally over. So, can a classic, legendary architecture actually be modernized to compete in a totally new era? To really get this story, you gotta meet our two contenders. On one side, you've got convolutional neural networks, or CNNs. Think of them like these super meticulous detectives, scanning an image with a magnifying glass, finding all the edges, textures, and shapes, piece by tiny piece. And then on the other side, our challenger, vision transformers. They're more like artists, stepping back to see the entire canvas at once, understanding how every single part relates to the whole picture. So with these two completely different ways of seeing the world, the stage was set for a massive showdown in AI vision. And this timeline just perfectly captures the drama. From about 2015 to 2019, deep CNNs like ResNet were the undisputed kings, no question. But then, bam, 2020 hits and vision transformers arrive and just completely take over the leaderboards. It honestly looked like the CNN's reign was totally over. But then, in 2022, something really unexpected happened. ConvNeXt showed up, signaling one heck of a comeback. So how did this takeover happen so fast? Well, it all came down to a fundamentally new way for an AI to actually interpret an image. Instead of scanning pixel by pixel, a vision transformer just chops an image up into a grid of patches, kind of like a jigsaw puzzle. It then uses this incredibly powerful mechanism called self-attention to figure out which pieces of that puzzle are the most important for understanding the full picture. So a cat's ear might be linked to its tail, even if they're on opposite sides of the image. That ability to see the global context, it was a total game changer. And man, the results just spoke for themselves. When these transformers were fed enormous amounts of data, they started setting all these new records for accuracy, leaving a lot of the classic CNNs completely in the dust. It really seemed like the challenger had knocked out the champion for good. But the story doesn't end there. Researchers saw the raw power of the transformer and asked this brilliant question: what if we don't have to choose? What if we could teach the old champion its rival's best moves? And right there, that was the birth of ConvNeXt. And here's the crucial thing to understand about ConvNeXt. It wasn't about inventing something totally new from scratch. Nope, it was a systematic modernization. The goal was to take a standard off-the-shelf CNN and, step by step, tweak its design, borrowing the most effective ideas from the Transformer playbook. Okay, so this is basically the training montage for our hero. First up, they copied the Transformer's simple patchify input. Next, to help the CNN see more of the image at once, they dramatically increased the size of its magnifying glass, the convolutional kernel, from the standard 3x3 all the way up to 7x7. Then, they adopted the Transformer's favorite method for keeping training stable, something called layer normalization. And finally, they just streamlined the internal building blocks to make the whole network faster and way more efficient. And this is the result of all that work. At a quick glance, yeah, it still kind of looks like a classic CNN with its different stages, but if you look closer, every single one of those building blocks has been re-engineered from the ground up with lessons learned from Transformers. It's this powerful new hybrid. All right, the training montage is over. The modernization is done. Now, it was time for the main event, putting ConvNeXt up against the very models that had inspired its transformation. Okay, let's look at the tail of the tape. This is the data from the ImageNet benchmark, which is like the Olympics for vision models. We're comparing model size, how much computational it takes to run, and most importantly, top one accuracy. You can see the classic ResNet 50 as our baseline, and there's the powerful Swin transformer. Now just focus your attention on ConvNeXt T. That's our comeback kid. And just to make this crystal clear, let's look at just the accuracy. And boom! Right here, this is the punchline of the whole comeback story. At a similar size and computational cost, the ConvNeXt tiny model didn't just match its direct competitor, the Swin transformer, it actually surpassed it. The modernized CNN was back on top. Now, of course, no model is perfect, right? ConvNext's huge strength is its efficiency. It's fast, it's easy to deploy on pretty much anything from servers to your phone, and it works great as a backbone for all sorts of tasks. Its main weakness? At the absolute biggest scales, we're talking massive datasets and models, pure attention-based transformers can sometimes still pull ahead in capturing those really long-range relationships in an image. So what does this all mean for the future of computer vision? Did the CNN win? Well, not exactly. The real winner here was progress itself. You see, the future isn't about choosing between CNNs and transformers. It's about combining their strengths. We're now seeing this explosion of hybrid architectures, brand new training techniques, and models that are specialized for specific fields, like medicine. This rivalry has pushed the entire field into a way more creative and powerful direction, expanding into super complex areas like video and 3D understanding. And look, this isn't just academic. This is where it gets real for all of us. This progress leads to more accurate AI for analyzing medical scans, which could help doctors spot diseases earlier. It means faster, more reliable defect detection on factory assembly lines. And it means more powerful and efficient AI that can run right on our phones. In the end, this battle for state-of-the-art wasn't a zero-sum game at all. The competition forced both sides to evolve, to borrow the best ideas from each other and create something way better than what came before. It really makes you wonder, what's the next great rivalry in AI? And what incredible progress is it going to unlock for all of us?